Hi there. This video is for the average value of a function, which is section 6.5. We need a formula for average value of function. It's basically the average value formula. To find the average, you basically take a bunch of numbers and you add them up. And then you divide by how many numbers there are. That's how you basically find the mean and average, right? So you add them up and divide by, how many numbers there are. In this case, maybe there's five numbers, so I would divide by five. In a continuous graph, it's going to be very similar, but it's hard to just count things because there's an infinite number of tiny little rectangles you're going to be using. Imagine we have a graph of a function, and we're going from 1 to 3. Just like all our other techniques, we're going to be taking a rectangle slice, or in this case, a slice of the function. Come on, pen. A slice of the function, finding how much stuff we have, and then adding it up for every possible slice, right? So we don't really have a region here. We have a function. So for every single point on that function, we found out its y value and we add them all up. And how many do we have? Well, we have the number from 1 to 3. Right? That's how many infinitesimal rectangles we have. That spans a distance of 2. So your formula for the average value of a function, that's going to be, well, you have to add up all the y values. So adding all the y values means you take each of those y values, add them up. That's called an integral. We're going to do it for every single rectangle, or in this case, every single little slice from 1 to 3. That's the adding up all of the y values. And then we divide by the number of y values, the length of the interval, which is just 3 minus 1 or 2. Remember, to find the distance between two numbers, you just subtract. So that's the average value of the function. For this particular example, in general, the average value of the function will be a to b f of x dx divided by b minus a. But the math people, they say, I don't want this big divided by sign. So instead of saying divided by b minus a, they kind of take this away and say, let's just put the 1 over b minus a up at the front. So they have this formula in the book, which may not be intuitively obvious the way it looks, but hopefully thinking of it like this maybe make a little bit more sense, because we're just adding up all of those y values and dividing by the number of x values. So that's the average value function formula. All right, so let's go ahead and apply the formula for example A. So we need to add up all these y values. So we'll be doing the integral from 1 to 3. The function is x e to the x squared. And we need to times dx. And we divide by, well, 3 minus 1 is 2. Maybe I'll do it the book way and put 1 over 3 minus 1 or 1 over 2 in the front. I'll write it as 3 minus 1 so people know where that 2 comes from. All right, so that's the average value. I don't have a lot of space here. So average, too early in the morning, maybe average equals this. So my average is equal to 1 over 2. And this integral, 1 to 3x e to the x squared, there's no like shortcut formula for x e to the x squared. So we're going to use some method to simplify this so it looks like one of our formulas that we know how to do. And the method that you recently reviewed, that you learned in your Calc 1 class, was substitution. So we're going to let u equal part of this thing. Usually something you want to get rid of, something that's complicated that makes it complicated. The exponential is complicated, but the best substitution you can choose is the x squared part. Choosing e to the x squared as your u value does work. It just ends up being more algebra. So it's not a loss if you were intuitively thinking make u be this whole thing. It will work, but it just a better choice is not to bite off more than you can chew. Just choose the x squared part, because making this into e to the u, we know how to antidifferentiate e to the u, so that's fine to leave it as e to the u. The rest of it's still here. There's still an x, there's still dx. And as you know, to complete our substitution, we need to convert all of the x's into u's. And so to do that, we're going to need to find the derivative here. And we need to solve for dx. That's du over 2x. And we'll need to take this and put it in for the dx. So this means that our integral is 1/2 x e to the u times dx, and dx is du divided by 2x. So here, what's nice to have happen is that we have an x divided by an x, and x divided by x is 1. And we also have a number 2, which can join the number on the outside, the 1/2 over there. So combining those numbers together and dividing out the x's, we end up with 1 over 4. 2 times 2 in the denominator is 4. Integral of e to the u du. And as I mentioned before, we do know how to antidifferentiate e to the u. We'll move up here a little bit. So we get to 1/4. The antiderivative of e to the u is itself. And then I do get a plus c. Oh, I forgot to put the values in there. This is x equals 1 to x equals 3. So this is still x equals 1 to x equals 3. This is still x equals 1 to x equals 3, right? We need to put the numbers in there. If I didn't have the numbers, I'd have to put a plus c. But since we have numbers, the c is going to subtract away, and we're just going to evaluate it from x equals 1 to x equals 3. Right, so please note you can't put x values into u, which is why we were hoping from previous assignments you would put everything back in terms of the original variable. It's a standard way of doing things. There are other ways you may know of, and that's okay, but I'm going to show you the sort of the standard way, which is to put everything back in terms of the original variable, so you can plug in the 1 and plug in the 3. So how do we put things back into the original variable? Well, we're the ones who made up what u is. This didn't come from like the problem. This is something that we used as a substitution to make it easier to antidifferentiate this. So I know what u is. U is x squared. So this just becomes, so the average is equal to 1/4 e to the x squared from 1 to 3. And then I plug in the 3, and I get e to the 9. And then I plug in the 1, and I get e to the 1, and that's my result. That's the average value. And if you want to know what that is as a decimal approximation, you can use a calculator. I'm going to be using Wolfram Alpha a little bit later, or I guess on the next example. So I'm going to show you what that looks like. This is Wolfram Alpha. It's a nice little knowledge engine, and you can put any kinds of math things in there you want. You can even put words in there if you want. This is 1/4, and then e to the 9 minus e. And so it gives me about 2025.09. So that's the decimal approximation. Oh, did I do this correctly? I got to press enter maybe? I forgot to press enter. Okay, it was doing a previous problem because I didn't press enter yet. So 1/4 e to 9 minus e. So it verifies that you typed it in correctly. And then the decimal approximation is right here. So I guess it didn't do all the stuff that it normally does. So there you go. Introduction to Wolfram Alpha. It's supposed to be really smart, so it's supposed to help you figure out if you made a mistake. And it gives you the result, of course, you're looking for. All right, so back to our problems here. All right, so that was the average value, and all the average value function problems, pretty much the same thing. You just use that formula, find the average value, do the math, etc. So let me show you a couple slight variations on this. Basically still the same thing, but students might see this a little bit differently. depending on your perspective. So example B, it says find the average value of the function. We know how to do that. The average value is equal to 1 over b minus a. It's still 3. I still use the 1 and the 3. I changed the function a little bit. Instead of x e to the x squared, I just simplified it to make it just e to the x squared. So we're going to do the integral from 1 to 3. These are x values, of course. And the function itself is e to the x squared times dx. And that's the average value function. So 1 over 3 minus 1 is 1/2, of course. And then we have to anti-differentiate this e to the x squared type thing. So you could try the same deal you did before with the u equaling x squared. And that gave us du dx is equal to 2x, or dx is equal to d over 2. You can try the same substitution. Some of you may realize it's not going to work so good. I'm going to show you why. So e to the x squared becomes e to the u. Dx becomes du over 2x. And I could certainly bring the 2 on the outside because it's a number with a number. So I get 1/4 integral from 1 to 3. I have e to the u, du. And on the bottom, I have x. And remember, I got to convert all of my x's into u's, and I didn't so far because we didn't have any division or cancellation of x's, but I know how to get rid of x. I just have a formula here, u is equal to x squared, so I just need to solve for x. So I can just square it both sides, and that gives x is equal to actually plus or minus square root of u, because I square rooted. So we end up with this formula. These are still x values, by the way. And we get e to the u over plus or minus square root of u du. See what's going on there. So the idea here is we're trying to simplify this integral so that we can use one of our formulas, one of our shortcut formulas, to find the answer. The original integral was e to the x squared dx. And the new integral, I don't think that's simple. I mean, we do have e to the u instead of e to the x squared, but what that gives us plus or minus square root u doing. There's no formula for that. It's just not going to work. In fact, I kind of set this up to let you know a couple of things. One is that the directions specifically say using technology. And so when you see that in your textbook, you're going to know to use some sort of technology device, either Desmos or I'm going to show you Wolfram Alpha to compute this. And the other thing is that there's kind of a dirty little lie in mathematics. They teach you all these integration techniques like substitution and all kinds of other stuff. But those don't work generally. They work on some things. Actually, percentage-wise, a very small percentage of problems can actually be done using any of the techniques you learn in calculus. Most just random integrals can't be done using any of those techniques, and we can only get a very close approximation using technology. So I just want that to be one of our tools. And so I made up this problem here so to emphasize those two kind of points. So we're going to do the integral of e to the x squared from 1 to 3 using Wolfram Alpha. So I'll just type it out. I won't even look for the integral sign. They have one, obviously, but I'll do integral of e to the x squared from x equals 1 to x equals 3. Okay, so we'll see that. Got to press enter. So you can verify that you actually typed it in. It understood you correctly. So it did. It can do things in terms of error functions, which you won't learn for quite some number of math courses. But it does give you a decimal approximation, 1443.08. And I think it can give you more decimals, perhaps. Remember, you have to use Desmos to get more decimals. You can get all the different steps and more decimals if you pay, but I don't want you to pay for Wolfram Alpha. You should be able to use the free version just fine for this class. So 1443.08. So we get all of the stuff. I'll just say didn't work. That way, when someone's reading what I'm doing, they go, oh, it didn't work. However, I can say, this one using technology, approximately, I got to remember the number again, 144308. There's my Desmos. There we go. 1443.08. So that's the average value of this function. The average value of all the average of all the y values from 1 to 3. All right, and then I have one last little twist on an average value function. It's not going to be much different in my mind. In example C here, it says the average value of this function y equals 6x from x equals 1 to x equals k is equal to 30. Find the value of k. So this is a little bit different because they already told you the answer, the average value. Let me get this in different color. The average value of this guy is 30. So they told you the average value is 30, but they didn't tell you the right-hand endpoint. They say x equals 1 is left-hand endpoint, 2x equals k is the right-hand endpoint. So we are going to use the same formula, but we're going to have to think about how to solve it using a little bit more algebra. All right, so the average value is equal to 1 over, well, it's the distance along the interval, so k minus 1. And that goes from x equals 1 to x equals k, whatever k is. And then, of course, we have our function integrated. There we go. The integral 6x is easy to do because it's one of our your shortcut formulas. It's just x to the 1, right? So we can do 1 over k minus 1. The 6 don't matter because it's multiplied. The antiderivative of x is x squared over 2. And we need to evaluate this from x equals 1 to x equals k. And by the way, we know the answer is 30, right? We know at some point this is equal to 30, right? So note, because we were told the answer was 30. Okay, so let's do some algebra. Well, what do we do? Well, we've got to plug stuff in because we know we're going from x equals 1 to x equals k, so we got to do this. Why did I say equal here? 1 over k minus 1. Maybe I said times and wrote equals, but I'm not sure. It's 1 over k minus 1 times the integral of that thing. So 1 over k minus 1 times 6 divided by 2 is 3. I'm going to plug in x squared for the top and x squared for the bottom and subtract. So just to note, I did 6 divided by 2 is equal to 3. And then I just plugged in the numbers into x squared like that. And I know the average value is 30. So remember, the average value is 30. So instead of just saying average, average, average each time, let me just put in 30, since I know the average value is 30. So what do I get here? I get 30 is equal to 3k squared minus 1 over k minus 1. All right, so we got to solve this equation. There's many ways of solving this equation. I think a lot of people would multiply both sides by k minus 1 to get rid of the fraction. Multiply this side by k minus 1. So these guys divide out, and then multiply the other side by k minus 1 and distribute. That would be a very typical way of doing it. Let me show you a little bit easier way of doing it for this problem. You may remember factoring is a way of simplifying expressions. K squared minus 1 is k squared minus 1 squared. We call this the difference of squares in the math business. And that factors to k minus 1, k plus 1. So in this case, I set it up so that factoring works. If factoring doesn't work, then you would indeed multiply both sides by k minus 1. And if you didn't think of factoring, that's fine. You can multiply both sides of a k minus 1. You get the same result, just a little bit more steps, a little bit more algebra to do, but you get the same result. Here, the k minus 1s divide out to equal 1, and we end up with, well, we still got our 30 over here. On the right-hand side, we just have 3k plus 1. And now it's pretty easy. I'll just divide by, you can work for me. There you go. I'm going to divide by 3. I get 10 is equal to k plus 1. And then I'll subtract 1. And I get k is equal to 9. And just double checking with the problem itself. And the problem itself said, find the value of k. So we definitely found the value of k. It's 9. So this means that in order to get an average value of 30, we would go from 1 to 9 and average all those y values together. All right, well, that's it for the video for this section. Hopefully this helped you understand how to find the average value of a function. And please reach out if you have any questions or if you have anything I can help you with. And I hope you have an enjoyable day.